right, so in this lesson we will simplify expressions again by combining like terms again with exponents and provide some sort of proof. This isn't foolproof, but it's better than nothing. It's a simple way of checking to see if your answer makes some sort of sense. All right, so our first expression is 3x squared plus x squared plus 5 plus 1. The first thing, of course, that we want to do is box our terms. So 3x squared plus x squared plus 5 plus 1. Remember, when we have exponents, we're going to check for the largest one. We have an x squared, a 5, and a 1. So the highest exponent with a variable attached to a variable is x to the second power. We have it right here. But there's another one. So we can combine them. We can put them together. 3x squared plus 1x squared. So we have plus 3 plus 1, which is plus 4. So 4. Don't forget the x squareds attached to them, or the x squared attached. Now we check for our x's. There are no more x's. Well, there are no x's. So then we check our constants. We have a plus 5, but we also have a plus 1. We know that plus 5 and plus 1 give you plus 6. So plus 6. So remember, we started with our original expression, which was 3x squared plus x squared plus 5 plus 1. We simplified it to the expression 4x squared plus 6. So essentially, the expressions 3x squared plus x squared plus 5 plus 1, this expression, and this expression 4x squared plus 6 are equivalent. They just look different. All right, so I'm going to write both of these out. 3x squared plus x squared plus 5 plus 1. I'll write that over there. And then over here, I will write 4x squared plus 6. Now let's go ahead and substitute a value in for x, for all the x's. I don't know. If I put a 2, I might confuse y'all with the 2's. 3's already there. Let's use 4, I guess. It's going to seem a little large, but let's use 4. Alright, so we have, instead of writing 3x squared plus x squared plus 5 plus 1, we can write 3 times 4 squared plus, remember, we see the x, parentheses 4 squared plus 5 plus 1. That should result in the same answer when you substitute 4 and 4x here. So 4 times 4 to the second power plus 6. Let's go ahead and do our math. Don't forget, we always do order of operations. PEMDAS. So, everything inside of parentheses is done. Let's do our exponents. 4 to the second power. Remember, this is not 8. This is 16 because 4 times 4 plus, let's do it again. 4 times 4 is 16. All right, so 3 times 16 is 48. So we did our parentheses because there was something to do. We did our exponents. We multiplied. No division. And we're going to add and subtract. So let's just combine all these actually. 48 plus 16 plus 5 plus 1. So 48 plus 1 is 49. 49 plus 5 is 54. 54 plus 6 is 60. 60 plus 10 is 70. All right. We should get 70 over here. Remember, nothing in parentheses to do. But we do exponents. 4 times 4 is 16, or 4 squared is 16. We're done with our exponents, so we move on to multiplication and division. 4 times 16 is 64. And 64 plus 6 is, in fact, 70. See how these two are the same? That is correct. So let's try another one. So we have negative y squared plus 5y plus 4 minus 2y. We check for our highest term, our highest term with the highest exponent. We have a y squared, we have a y, we have no y's, and we have a y. So this y to the second power is the highest. There's no more. There's no more. So let's just write that one. Bam. Now we check for our y's. We have a y term here and a y term here. So plus 5 minus 2 is plus 3. So plus 3, don't forget the y. And we have a plus 4 for our constant. We don't have any more constants, so we just bring it down. Plus 4. All right. So remember, this expression here is equivalent to this expression here. They just look different. So negative y, the expression negative y squared plus 5y plus 4 minus 2y and negative y squared plus 3y plus 4 are equivalent. They just look different. All right, so let's prove that. So let's start off with our first one. Negative y squared plus 5y plus 4 minus 2y. Okay, that should be equivalent to negative y squared plus 3y plus 4. So we have to choose a number and to substitute in for the y's. Let's choose 2, just because I know some of you are going to choose 2 at least one time. So y equals 2. All right. Now remember, if it makes it easier, let's place a 1 here. So negative 1, 2 times 2 squared plus 5 times 2 plus 4 minus 2 times 2. Remember, we do PEMDAS. We do order of operations. So we don't have anything inside of parentheses to do. Let's do our exponents. We only have this one. So 2 times 2 is 4. Plus 5 squared plus 4 minus 2 times 2. All right, now we're done with our exponents. We do multiplication division. Once again, we're only going to have multiplication in this one. Then we'll be done with it. So negative 1 times 4 is negative 4. Plus 5 times 2 is plus 10. Now, let's back up real quick. Remember, this is a negative 1 times a positive 4. Negative times a positive is a negative. 1 times 4 is 4. Okay? We continue with this plus 4. We have a 2. We treat it like a negative. A negative times a positive is a negative, so we're going to write minus. 2 times 2 is 4. Now this we can all put together, so negative 4 and 4 give me 0. 0 plus 10 is 10. 10 minus 4 is 6. Alright, we should get the same thing over here. I'm going to put the 1. Negative 1 times 2 to the second power plus 3 times 2 plus 4. Remember, I substituted 2 in for each y. So we do exponent, well, that's inside parentheses, so we do exponents. 2 to the second power is 4 plus 3 times 2 plus 4. So a negative times a positive is a negative 4. Positive times a positive is a positive 6 plus 4. Remember, I can just combine these. Plus 6 plus 4 is plus 10. Plus 10 minus 4 is 6. That's exactly what we were supposed to get. Alright, we got one more. Alright, so let's box these terms. Y plus 3y squared minus 4y squared plus 5 minus y. Y squared, no y's, y. So let's take the y squared plus 3 minus 4. So plus 3 minus 4. They're more negative. So negative 1 y to the second power. Then we have y minus y. Remember, 1y minus 1y. So we have 1y minus 1y, which gives us 0y. So we just don't write it. It's just gone. They're just gone. There's no point in doing that. And then we have this plus 5. Plus 5. All right. So let's go ahead and do our statement. The expressions, this one first, y plus 3y squared minus 4y squared plus 5 minus y, and this small one, negative, I'm going to get rid of the 1 because it's still there even if I don't write it, minus y squared plus 5 are equivalent. They just look different. Alright, so let's make y equal 3 in this one. Yeah, let's just do it. So we have the long one, y plus 3y squared minus 4y to the second power plus 5 minus y. I like to take a moment just to write the ones here. Okay, that should be equivalent to negative y squared plus 5. Write this 1 in front. So let's do it. 1 times 3 plus 3 times 3 squared minus 4 times 3 squared plus 5 minus 1 times 3. A lot of this, the whole point in kind of doing this, like simplifying, is so that we don't have to do math with this later on. We can just do math with this. All right? So exponents, because there's nothing inside. Okay, so 1 times 3 plus 3 times 3 to the second power is 9. Minus 4 times 3 to the second power is 9. Plus 5 minus 1 times 3. We're done with all our exponents. So let's fill out this multiplication. Let's just do it. Let's evaluate. So 1 times, that's multiplication right there. 1 times 3 is 3. A positive times positive is a positive. 3 times 9 is 27. Negative times positive is a negative, so minus. 4 times 9 is 36. Plus 5. A negative times a positive is a negative, so minus 3. Alright, so let's do this in chunks. 27 and 3 give you 30. And then let's write down minus 36. 5 minus 3 is positive 2. Alright, so 30 minus 36 is negative 6. Negative 6 plus 2 is negative 4. Now let's see. If we get the same thing, we should get the same thing. Negative 1 times 3 squared plus 5. exponents. 3 times 3 is 9. All right. Negative times a positive is a negative 9 plus 5. And negative 9 plus 5 is in fact negative 4. So both of these expressions, when you substitute in 3, give us negative 4. All right, thank you once again.